We're going to look at solving a logarithmic equation. So I've written down two rules we'll need to keep in mind just for our question, which is below. We have log bracket x minus 1, and then subtracted by 1 is equal to negative log bracket x plus 2. And they want us to find essentially values of x. In order to do this, we have to keep a couple rules in mind. So the first thing I'm going to do is I'm going to move our negative log of x plus 2 to the left side of the equation. Okay, and what that'll leave me with, and actually I'll show you first. We'll have log x minus 1 plus log x plus 2 is subtract 1 is equal to the value of 0. And the reason I've done this, or I've gone about doing this, is because I want to relate it to this rule we have up here. Is the, I think, product rule of logs, it's called. Did you guys go through this last chapter? Somewhat? Okay, so if we have log A plus log B, it can be simplified.
Oh, we did.
Yeah.
We didn't really have to know. We did it once, a tiny bit on a worksheet.
Okay. We can simplify it as log A times B. And vice versa. If we have log A times B, we can expand it by putting log A plus log B. So what I have here, if we think of this as being our A and our B, I can now, I guess we call it simplifying it by writing log, in bracket, and our A is x minus 1 times our x plus 2. Okay. And then I'm going to move our negative 1 to the other side of the equation. So it becomes a value of 1 here. Okay. So when we do this, we are going to, I would like to try to get rid of the log on the left side. So I need to make this some form of log. So if you recall our original up here, a to the power of b is equal to a value of c, can be written as the exponent is equal to the log of the base equal to the solution in the end. So let's put this as an exponent. This is the exponent of 1 to the technically power of 1 here. Okay, so we can try to put this into some kind of logarithmic function. If we think of base 10, okay, so if I had log of base 10, I'll write it in blue over here, log base 10, our exponent is equal to 1, so we need it to equal the value of 1. Okay, what would our c value have to be? Do you have any idea of how we could write this? Log base 10?
10?
Yeah, it's actually 10. Log base 10 of 10 is equal to 1. With that being in mind, we can essentially replace our 1 with that value. Okay, so we can replace 1 with what we have here, right in blue, log base 10 of 10. And over here, we technically have log base 10. I guess we don't have to write it in, but log base 10 of minus 1 is plus 2. There we go. We can expand what we have inside of these brackets. So log base 10, and this will become x squared minus x plus 2. So I think we'll get plus x minus 2 would be our expanded form of that, is equal to log of base 10. Can you think of anything we can do if we have a log base 10 on both sides of this equation?
Divide them so they cross out?
Yeah, essentially we could divide them so that they'll end up crossed out here. So if we were to divide this side by log 10 of 10, and we divide this side of log 10 of 10, okay? On the right side, do you know what we're left with if we divide a number by itself?
1.
Yeah, we're left with just 1. And then on this side, our log 10s essentially cancel out, and you're left with your x squared plus x minus 2. And technically, it's above the value of 10. What we want, though, is, it's a little far apart, let's move our 10 back to the other side so we're no longer working with fractions. So we move this 10 back, it'd be multiplied by 10, right? So we have x squared plus x minus 2 is equal to the value of 10. And this is very similar. It's a trinomial, and it's probably a quadratic that we could factor if we set it equal to 0. So let's move this 10 to the other side of the equation. We'll get x squared plus x. When we move the 10 over, we'll get minus 10, so we're going to end up with our negative 12. Does that make sense? Yeah, okay. So from here, it becomes a factoring issue. Two numbers that multiply to negative 12 and add to a value of 1. Well, that'll give us positive 4 and negative 3 are equal to 0. We would set both brackets equal to 0, so we get x plus 4 equals 0, and x minus 3 equals 0, which means x is equal to negative 4 and x is equal to 3. So we have two answers here. So we need to go right back up to the beginning of this question. I'm going to copy this part, whoops, because I want to bring it down and work on it. Okay, so let's paste it down here. We have a right side. Oops, that's not my right. My right side and left side of the equation. Okay, so we can go ahead and try plugging values of these in to see which of them, or if both of them, are possible answers. When I plug negative 4 in, I'm going to get negative 4 and negative 4. And this will give me log base 10 to negative 5, which would be an undefined value. If we put it into our calculator, we wouldn't be able to find it. And the same thing would happen over here. We'd end up with the negative log of negative 2, again, an undefined value. So we can kind of deduce that negative 4 is non-logical for us. It's not something we can work with. We can plug in our 3, though, and see if we get it. So here we would get log, at 3 minus 1 would give us 2, subtract 1. And on our right side, we get negative log of 5. Okay. And we can plug in these values to see if the left side will equal to the right side. So let's see what we get here. Log 10 of 2. Okay. Subtract 1. Oh, I got to subtract 1. Okay, so we have our answer written in our calculator. And we'll go negative log base 10 of the number 5. And lo and behold, we get the exact same answer. So we've shown that the left side of the equation is equal to the right side of the equation.